Hey guys, it's Steven Mossbrucker from the Skool hardware development group, and today I wanted to do a first thing. I've never done this particular style of video before. I've been teaching online since, oh man, 15 years or so, first starting with YouTube and then Udemy for the last 4 years, but I've never done a reaction style video or listening on one screen and recording desktop audio in and then voicing over it. Right now, this is going to be exclusive only for Skool. We're going to talk about this Micronics Micron system that I posted about, and it seems like they're having some issues. And the video kind of spoke to me that, hey, maybe this might be a good thing to talk about with the Skool group and some of my knowledge and some of the things I'm talking about with the Skool group of how to avoid some of the things that they are hitting here. So it looks like they're kind of stuck between a rock and a hard place and on the development of this Micron printer. And so we're going to talk about this and do it all reaction style. We'll go all the way through. This is a 35-minute video from a YouTube channel called Stranger Parts. I'm unfamiliar with this YouTube channel. 73,000 subscribers. This is the first video I've ever seen from him, but he seems to be very thorough. We may jump around a little bit to get around some of these things. And again, I'm new to this, so stick with me, but I'll see if I find some videos like this in the future that are worth this type of video, of this reaction video. It's more of an analysis video anyways.
Oh, this bin's broken. Ah, jeez.
Link will be in the description.
This is not ready for anybody to buy.
First thing here, I mean, looking at it, the packaging looks very, very good. I haven't put on the Skool group yet. On the Skool group, you find a couple things. You'll find two main classroom items. One is basically the product development process, which is this Google Slides, this huge document here. Right now, I'm at 58, 59 slides, but I'll be adding more as we go. And right now, current phase is in resource gathering, and then I'll clean it up. So right now, I'm just adding information into it, and then I'm going to start to cut it and smooth it out, right? Another one is the resource development resources. And so in here, we have the two design and safety FAMICA, and then bill of materials, what a bill of materials will look like, and then kind of a to-do list to plan your plan your development and your actions that you're going to do personally. Generally, you're only going to do that for personal, and then in the future, you would do something more advanced for group meetings, such as a Gantt chart, kind of like this. This is a very clean way of presenting your information that looks very professional to the interior group. But if you're looking for just, scheduling, then you can use that to-do list. So, some things that I have not, that I do have some information on is packaging testing. And so that's coming up soon. But I mean, according to this, there's a lot of, the packaging here looks very good, but we'll find in the future that some other parts didn't fare as well, mainly because of their development process. They used FDM to create a lot of these parts.
Okay.
More on the rigid foam side, but this is stainless steel, so it's okay.
Ta-da! Okay, I'm gonna put this back here so I don't break it. There's a little tray. This is the scoop for removing prints from.
So you're seeing also that we have rigid foam here, and so we find out later that this guy's got some damage to it.
From the wheel chain. I like these guys' style already.
And maybe one of the things that led to that is they added mass by putting things inside. Of course, that's the logical way of packing things. Inside here is the powder. This is basically an SLS printer. So go ahead and check out, I'll also post the Micron's video about their Micron printer, so that'll get into it, but basically it's an SLS printer. You put in powder, and it will use a laser First, it has halogen lamps to heat the powder right up to its sintering point. It's actually sintering, so it's not melting, it's sintering. So it heats the powder right below its sintering temperature, and then the laser knocks it over that sintering temperature and causes that powder to melt into a ball and melt with the nearby powder next to it. And then it will load layer by layer. So inside here, this is actually the powder itself inside here, and I think this is like a couple kilograms of powder, right? Powder can be very dense. The packing density of this powder is, because you have variable particle size, and you can talk about packing density. You can look that up. I think for a ball is pretty high. I think it was like 66% or something like that. But if you have balls of varying sizes, you can get extremely high packing density. So even though that looks like a regular gallon of water, it's extremely dense. It's basically solid plastic. So adding that type of weight into here could cause damage.
Is the fume extractor. Again, 3D printed.
Pretty good to add. So this is a part of the safety Famica. So for example, here the safety Famica. So it's like, okay, well, what could happen? Possible failure modes or effects of safety incidents. So, inhaling powder for the user. Okay, what's the effects? It can cause health issues. And so the controls are developing a procedure, including mandating PPE, including systems like this that help control the powder dispersion, right? And other disclaimers and warnings and other things like that. And you can learn more about some of the things that you can put for safety. Yeah, so here, for example, for safety, right, we talk about the kind of the pyramid. So here you go. Safety devices. So in this case, it's kind of a safety device. They have this fan to suck out the stuff, to suck out the powder, so you don't inhale the powder, because this powder is very microscopic. It's going to get caught in your lungs. It's going to be very hard to be able to cough it out. Warning devices. In this case, there is no warning device. Provide hazard labels. They're going to have hazard labels everywhere inside the and then they're going to have it inside the procedure. So basically, they have this guy, but this will not prevent you from. It will not prevent you from pouring the powder in without having the fan on. So that this is sort of not really the case. It's kind of a band-aid. I would count that fan is a PPE, because basically, as I said here, is that so for example, passerbys, if they're not wearing PPE, they can be affected. Can be great protection, but this is the worst level. Main reason is, what if the user is not wearing it or using it? So in this case, they are not what if they're not using the fan? It doesn't help. So same thing as a dust respirator. If they're not using it, it doesn't help. So here they're using basically the bottom three, and they're not using the top two. These are the main two. Top two. Try to design it out, or add safety devices, and then also add warning devices to warn the user that something's going on. In this case, none of those are there.
This is the nylon powder.
1 second. Let me go ahead and skip the ad.
One of the things I've been curious about is how strong this stuff is going to be. Oh, it's very strong.
So according to here, I mean, it makes parts.
Yeah.
It makes parts pretty well. And then here's the next interesting thing.
Okay, so I have 4 halogen bulbs: filter side, door side, laser aperture side, and IR sensor side. All right. Oh, I see. Laser.
So remember I said they use halogens to lift the temperature of the plastic above a certain level, right? So it lifts the plastic above a certain level, and then to right below its sintering temperature, and then laser knocks it over. So now you're having a user install these bulbs, I'm assuming to prevent damage in shipment, right? Number one, you can have the user damage it, and so now the machine is basically useless, because the laser does not have enough power, watt density, to melt the plastic without it being right up next to the sintering temperature. And number two, you're having the user expose themselves close to live wiring. Do you have any interlocks such that when this door is open, that the lamps do not come on? These lamps will not energize, or for whatever reason. So again, back to your safety Famika. What if the user opens the door and then and then the halogens are energized? Effects of safety incident: burns, electrocution, bulbs exploding, shooting shrapnel everywhere. Because again, also these halogens can explode if you get oil from your hands on them. That's why he's wearing gloves. So potential cause injuries, right? And so what are your controls? Interlocks. And then the controls are these guys. So here you have interlocks. Number one, a good way of doing it is making such that the user never has to touch it, right? And that they last a really long time. They last the life of the machine, let's say. So there you go. You designed it out and they don't need to touch it. But now you have them touching it. So incorporate separate devices. Let's say you weren't able to make it such that it's not handled because you're worried about it in shipment, whatever. So here you have interlock, doors open, bulbs are not on. No power to the bulbs, etc., etc. And then, warning devices, when the door's open and the power's on, it starts doing horns or whatever. And then, labels, electricity, hot, etc., right? Pinch, electrical hazards. But just another thing that could happen that could cause either a system Famika issue or a safety Famika issue. So system Famika is user is installing the bulbs, installed incorrectly, system does not work, and now you have people not happy with your product. And this has a lot, all with the bulbs. So now also, how are you going to handle the the dead on arrival or RMA claims that, hey, my bulbs don't work? It's like, okay, well, does the bulb actually not work, or did they uninstall it incorrectly, and now we have to have this back and forth with the customer? And this is just going to you're going to have so many of these lines, because generally you want one of each, right? So it'd be like light bulb, halogens in different possible failure modes because the user is installing it.
Is on the side. Yeah, I got it.
So, and that's basically the worst case scenario. You have it in design and the safety Famika at the same time.
I see it now. Down to do this. I need gloves.
And also you have the user tipping the machine upside down. What type of interactions does that
Gently
have?
twist the gear and the back and ensure the recoder is moving smoothly. Yep, beautiful.
Exposed gears. Obviously no motors here. Is there anything else here? We got insulation inside, fiberglass insulation here. Motors back here in this back corner. It's is in this case back right or front right, and then when you flip it around, the motor's here. So again, anything else here, any interlocks that are done, right, to make sure this guy is in. It's watching this video, you would see that there's a lot of sensors that this machine triggers off of. But then you have the user testing. Okay, sure.
Okay, so that.
But you have pinch hazards here. The user's testing it. He has his fingers inside. They get pinched. Peels the skin off. Now it's contaminated the machine.
That gear.
He's not wearing gloves here. Is oil going to affect the nylon? Right? No gloves. Touching inside.
Is attached to this arm, and this arm is what wipes a new layer of powder across the build plate here.
And now you just touch the build plate with no gloves, right? Obviously, I come from semiconductor background, so that is a huge
this
no-no.
arm and this.
Right, so that's where I come up with that type of thing. How clean does this need to be to not affect? Probably only going to affect the first layer. You're going to take or first build. It's going to take all the oils and things from your hand with that nylon. But is it possible other ramifications?
Arm is what wipes a new layer of powder across the build plate here to be melted by the laser. I don't know if you can see that, but there is a tiny bit of powder coming out right there, and that's kind of the fill area where the powder comes up from the bottom. And then we're gonna clean the IR window. That looks pretty good. So now we stick this in.
Cleaning with chemicals, right? Is this chemical provide? Now you have the user using chemicals, right? Is there proper MSDS of what you should use? Different types of call outs for it, right? Isopropyl alcohol is extremely flammable. You know, you're cleaning with a flammable fluid. You're putting in air halogen lamps, safety Formica, fire from chemicals used to clean these components, and high temperatures, right?
Printer.
Vapors are happening. It's inside a closed environment, and you have halogen lamps, right?
I think that's in there.
You have to be very, for the safety Formica and design Formica, you have to be very creative to think about what's all the possible failures and safety issues of my machine, and how can we go over those issues, right?
Close the door.
I mean, it could be as simple as, hey, this strap snaps off for the design Formica. Okay, how can that, how will that impact? Or just like I discussed in here about weight, what happens if this thing hits my foot? What happens if I drop this thing on my foot? Does it have sharp edges that's going to put a puncture into my foot? Does it have a warning label on it? How would the warning label interact with being inside this hot environment? Things like that.
Okay, I'm going to insert the SD card. And we start the demo print. Okay. Here is a file called Scotty Demo. I don't know what to think about that. All right. 2 hours, 358 layers. Go.
Check this out. Watch this. So.
All right. Let's see. It says, observe the first few recoating movements to ensure a consistent layer of powder is laid. Doing some homing. I think it's supposed to be pushing powder onto the build plate right now, but there isn't any coming out yet.
And there you go. So again, this would be some other good things here. Obviously, you have this light. I don't know if this is from the halogen or if this is an LED here for heating it up, but this is where you can easily do, some sort of thing that we talked about here. Warning devices. Lights come on when certain situations are satisfied. So flashing, to get the user's attention, to bring it to, because this is a pretty small display. So, if you look at the front area of the machine, this is probably 1% of the front area of the machine. So try to alert the user to look at the screen here. So system failure, auger jam. So basically the auger is what's moving the powder up to the top of the machine.
Auger jam. System fail.
And of course, the auger doesn't work. It doesn't move powder from inside the reservoir at the bottom of this. It's got like basically a bucket on the inside, so it doesn't bring powder from the top of all the way up to the top of the bucket. And so now, basically, the machine is non-functional.
All right.
I actually
Holy smokes, another one.
used to sell apartments for $9.45 an hour.
I had a
Okay, now it's pushing powder, so I think we're in good shape.
And boom, there it goes. So basically, a big portion of this is him going through and talking to the two individuals at Micron. Micronics, sorry. Micron's the model, and Micronics is the company, to diagnose this auger failure issue. So basically, they have this auger at the bottom, right? And it's just a regular DC worm gear. Here's the DC motor right here. You can see the front end and rear end cap and the black housing in the middle. And it's just a worm gear auger, right? And then there's an auger that goes up and it sucks powder in. And the problem that he's having is basically it is getting jammed at the bottom, that it's basically this packing density is so high because you have these different particle sizes that it's jamming up inside, just caking up. And this auger is struggling to be able to overcome it. And so they talk about, if you watch the full video, they talk about that they were planning on adding a way of being able to go forward and then reverse and forward, forward and reverse with the auger, but that was never implemented. And we learned kind of later why that probably is.
Is that right? Okay.
Correct.
And here I'm talking to him on the phone, and basically now he's here, trying to rearrange the internals of this guy to try to free up this caked stuff. But the unfortunate thing with this powder is you hit it with a hammer, it's just going to pack further. So you're just going to keep increasing the packing ratio by jittering it and getting it to tighten up. So basically they try over and over and over again, and then they ask him to use, luckily he seems to be pretty experienced, they ask him to break out a power supply, right, DC power supply, and work with live voltage to go back and forth with this DC motor, this DC auger, to try to free it back up. And basically the same thing as I talked about with the packing ratio. He just is basically working it in and compressing it down tighter and tighter and tighter, right?
For longer than running it in reverse orientation.
All right, and then just better.
Let's keep it until it fills up the center.
Let me put a mask on since I'm starting to mess with powder.
People are starting to get frustrated here. No procedures for doing this, so he's telling them over the phone, missing some of these PPE things, and you see that they do have some warning labels right here on the front, so that's good. But any sort of PM or maintenance manual not yet developed. These are early prototypes. Kickstarter was launched shortly after this. It's the third day of the Kickstarter now, and it's been, I think, last time I looked, $1.3 million in funding. And this was done 2 days ago.
The auger unjammed, and hopefully that'll work when it goes into the printer now.
Okay, great.
So yeah, obviously on the production machines, the printer will be able to do this back and forth unjamming thing by itself automatically when it detects a clog. I didn't consider needing to do this when I designed the PCB.
I think this is the electrical guy, specifically, if you watch the videos.
Okay, so then we might have to actually take apart the auger.
So basically he did it again, it jammed again. And so now they're saying, hey, we need to disassemble this guy for a FA, failure analysis, to kind of look inside, see what's going on.
Yep.
So
he says, hey, it's going to take...
You want to turn the lead screw so that to push the recoater off.
Handling fiberglass with bare hands.
Access to the entire auger.
And so some sort of heating base here. You can see a warning heat label on there. This is a standard warning label for heat. So it's got some sort of a regular contactor here, and then also the halogen lamps to heat the top. Because it's mainly so this is like heat the bulk. So this is heat the bulk of the material. And then the top, you just need to be hotter than the bulk. Remember, this is all plastic. Conductivity is pretty low with plastics. This is PA12, which is a nylon, polymid nylon. But the packing density is high, so you got pretty decent thermal conductivity. Again, generally the particles are roundish, so the contact area is very small. But so yeah, this guy is just kind of heating the bulk up, and then the halogens are heating the surface hotter than the rest.
Let's tape the glass plate back.
And so here's the auger that he's going to start messing with, right?
Onto the top.
Okay.
On October 9th.
Yep.
Again, breaking out the hammer, knocking on it,
Yep. Then we
bringing
can
it up.
gently pull it outwards.
Okay.
So it sounds to me like he's reading from a procedure or reading from memory. So obviously, this is something that he knows very well. They've worked on this machine for 2 years, as they state in the Kickstarter ad. So he knows it pretty well, but it doesn't seem like any formal procedures.
And then slowly turn it up.
And here you can see powders
180
coming out.
degrees.
This way?
Yep.
And also, this can be very hazardous for animals as well. You get this on the floor, animals come, sniff it up, It's bad for it's bad for basically everybody. Small children, animals, gotta be careful
That
with
way
this kind
the
of stuff.
opening is facing the top.
Yep, got
And
it.
you can see it's coming out of everywhere, dropping all over the electronics, inside the machine, maybe movable parts. This stuff can be, it's not powdered steel, but it can still get into gears and cause damage. So where is that in the design Famika? How do we prevent that from happening? Do we have any sort of wipers to keep it out? Is there some sort of procedure to go in and clean it up automatically? Or do you need, customer intervention? What's involved with the customer intervention? What's the hazards for the customer intervention? Does this design Famika now cause a safety Famika issue?
Okay.
And then I should have asked this, but is there like a bucket or something, or a bin?
You see
or
he's
something that you
asking
can
like
empty
this
the
after the
powder
fact,
into?
so
What about
probably
just
not.
the sift?
So probably not already released procedure. He's asking for a bucket, and he's got their sifting bin. So he ends up
Bin.
using a
That
sifting bin.
would work great. Why it's working outside but not inside the print? And then is all the powder like out already? Like
No.
powder coming out?
It's almost there.
Just trying to figure out
So here listen to what he says next.
why it's working outside but not inside the printer.
I mean, once it comes out of the printer, it's jammed too, right?
Yeah, like why? What's the difference when it's
Yeah, I don't
inside
know.
the printer? It run it.
So yeah, basically have issues with it inside the printer versus outside the printer, and
versus-
trying to figure out this FAA of why is it working outside the printer but not inside the printer, right?
just directly outside.
So basically this would be something that you'd bring up. Okay, now this is definitely going to go into the design system Famika. Okay, I have a auger jam inside the printer. Okay, what do I do? Like, what are the controls? Maybe, FA, what is it? Is it the auger dimensions? The tolerances between the auger and the wall are too tight? Or is it the opening for the powder to get in is too big? Maybe it's jamming up because there's particulate in the powder. Maybe I need to put some sort of filter there, but then how do I deal with the filter? Et cetera, these things, right?
That's what's confusing me so much.
Yeah.
Generally, you want to catch this before
totally
it goes to
sure.
the customer first, but we'll talk about that shortly. I have another thing for that. So basically here, very cool. Got diagnostics window. It shows out all of his parameters here, right? He's basically saying this is the current for the auger, right?
Okay.
And this is like the voltage of the power supply or something, and you can see it's got multiple screens here.
Yeah. I sort of felt like maybe the auger was like a little off center or something when I had it all the way off. Yeah.
Basically here you're hearing it lock up, pretty much. But the cool thing is that it does have a warning that it told the user exactly what's going on, which is good. So obviously no real way of fixing it until he got into contact. Maybe later on they'll have, you can see he's got various Kickstarter projects. These are Caveras, I believe. So he has various other projects here that are Kickstarters. I think this is the Air, the brand new Air that just came out, the Cavera Air. That just went through Kickstarter. So he is, pretty used to these Kickstarters kind of early development. But maybe this just, for example, on Bamboo Labs, I have a Bamboo Labs printer. I was one of their early backers for their first Kickstarter for the X1 Carbon. It has on the screen where you can, take a picture of the QR code and it brings up the diagnostics. So the diagnostics are not on the printer itself, but you can get it on your phone.
Is it loosening up?
So
is powder coming out?
Obviously,
right
that doesn't exist here. I mean, it basically just says auger is this and then good luck, pretty much. So you have to contact company, blah, blah.
well, that thing on top's tilted the wrong way, so.
So he's talking about here, basically, he thinks that this auger is like tilted or something, and so it's rubbing against the inside of the tube, and that's why it's jamming up. Or there's so much force on it from the powder that's compacted that it's, putting too much torque on the thrust bearings on the inside, or or pinching something, right? And I've had some designs like that in the past where I haven't had adequate support when lifting. For example, I built this bike rack for a motorcycle, and so when the machine was halfway down, it was fine, but when it went all the way down, it was tilting at such a way that it was pinching on the bottom, and it required massive amounts of torque to overcome that to start to bring it back up. And then once it got halfway up, it was fine. It would start to not be torqued as much, and it would start to come into being more aligned and not pinching on the nut that was on this Acme all thread.
Oops, I ran it the wrong way, I think. Yeah, it's working now. Maybe just run it a bunch? What do you think? Well, fingers crossed it won't happen anymore. Well, I think I'm in business for now. I'll give you a shout if I hit any more issues.
Fingers crossed.
All right. Thanks, Henry. And I'll let you know how this goes.
Yeah.
So here he's, showing showing the system working. Also, because it's heated, I'm curious about any sort of thermal issues here. So I go into thermals here, right? So this is some of the basics here. So possible to be touched, maximum for metal you want 65, plastic 95. So may need to be touched if you're going to touch it over 5 seconds, 60, 70, 85, and this is all in Celsius. Needs to be handled above 5 seconds, 51, 56, 60. So, for example, the outside of the machine, I would say needs to be handled more than 5 seconds. You're moving it from one place to another, or it starts to get unstable, or a cat tries to knock it over, or whatever. So the outside of this machine is designed to be handled. So I would say, if it's a metal enclosure, are you below 51 Celsius, right? And also warning labels, hot. Right? Same thing with that one. So that's a good example of up here, the kind of designed for safety mitigations, right? So basically, do you need does it need to be there, right? So design it out, right? And then incorporate safety devices. Do you have ways to isolate the heat such that when it's touched or something it turns off or whatever? And warning devices, obviously you can have warning printers hot, flashing on a screen or something, or even that flashing light that he has on the LED bar. Provide warning labels, so hot warning label. Sure, it may make your product look not as clean on the outside, but hey, at least it shows that you have attention to detail. Procedures, something to say on the display, or something to say in your operating manual of this is the normal procedure, or as you're going through the menus of the display, you have it say, hey, this printer is going to get hot, or use, provided. Generally, if you have PPE, provide it. So, okay, here's, here's the thermal gloves provided with it, right? So he finishes all this. Basically, it finally works for the first time, and then now he gets here
to remove the powder cake from
get the powder cake.
The build chamber here.
The cake, powder cake.
And that has the parts embedded inside it.
So basically, he gets into taking this powder out, and when he takes this powder out, it obviously is a big, messy process.
Turn that on. So
here he's using his quote-unquote safety device, or his PPE. So he's got basically his fan PPE and then his face mask PPE.
Goes in here.
And so basically what he did is you use it as like a pooper scooper, pretty much. And it's all 3D printed, by the way. FDM.
Like
and then so you go down and you scoop the cake out.
There for a minute, and then we raise it all the way up. And then we slide this down underneath. Turn that on.
It's like maybe have this guy automatically turn on, turn off with something. If there's something in front of it, turns on. Maybe.
Goes in here. Okay, now.
And so you scoop it out, and then you let it drop in, and then any sort of spray nylon dust that moves around gets sucked up by this guy. So overall, for kind of a cheaper product for SLS, I mean, generally SLS printers like this are 20,000 or higher. This machine's 3,000, 4,000.
Still in here.
And they provide you a little scooper. Now, of course, there's no mounting. I think there's no mounting provisions. The only mounting provisions for this guy is on this shifter. There's no mounting positions to put it back on the building base. Again here, are the corners hemmed? Can you possibly cut yourself? What's the QA on this, etc., etc.?
Okay, supposed to put in more new powder in here, so about a quarter bottle.
Now, this is the interesting part. Check this out.
And then we shake this for 30 seconds to 2 minutes. Oof. Pour the sifted material, which is down here, into here. So we turn the fume extractor on.
Okay, so it did have, I didn't remember that part, if it had provisions to attach on the build plate. It does. Okay,
So
good job
goes
for that one.
here, this spout rotates down.
And this is fully
and then
3D printed, by the
pour
way.
this back in here. Turn that off. So let me bring that in here. This is my
Here's his,
Rubber Freight Special sandblasting cabinet. So, let's give this a shot.
and here he sandblasts it, right? Obviously, another hazard there. Okay, let's go ahead and listen to this part.
To just give a little bit more clearance. See how this goes. It's going to take 6.5 hours.
So basically, he had an issue with the original sliced part did not work. There was supposed to be, basically, there's supposed to be like some clearance between these springs, such that the springs move
out. So, and the knees just look like they got fused. So that's a bit disappointing.
So this is supposed to move. This is basically a mechanism that these pincers go back and forth. You can see the gears right here, and then it looks like this is just like a radial spring, so it like springs back to in place, and then these gears sync the two sides together. So this is supposed to be a cool like print in place mechanism, but it looks like their tolerances were off such that now it's fused. So did they try it before they shipped it? I don't know.
So the real test here now is going to be to do the second print. So I have the same model, the pincher model. I talked to Henry, and he said to make a slight adjustment. Go ask Henry and Luke. That the hardware was jammed. I pulled it out a couple times. Then it's going to take 6.5 hours.
Yeah, watch
I'll be
this.
back.
Nerve failure.
Jeez, I'm having all sorts of problems. So first, the hardware was jammed. I pulled it out a couple times. Then it said check scoop sensor, and now it's saying that the card is corrupt. I'm losing faith in this thing. I don't know. Go ask Henry and Luke. Okay. I talked to Henry. I got instructions on how to fix the sensor error. And maybe one more tip on fixing the auger. That's the sensor. So Henry said today he's going to send me a new auger assembly, which probably will fix this whole thing. What a pain in the butt.
So you got it working again?
And that ends the print. Damn. Fault at layer 649. Oh. It did not finish. I have a recoat fault at layer 649.
So basically, Recoder failed at the 649th spread. So basically, each time it prints, it has that spreader that you saw at the beginning will work the powder across and deposit a thin film on the print bed for the laser to center. And it seems that now it has thrown a fault error that, hey, I was not able to complete this.
And that ends the print. Damn. I don't know what that means. It is kind of cool to see it mid-print. Let's get the print out of here. This.
Now watch this part. See all the powder coming out?
Boy, oh, I'm getting powder everywhere. What's going on? Oh, this bin's broken. Ah, jeez. There are cracks in this bin. I don't know why, but there are multiple cracks in it.
So this is an FDM 3D printed bin, right? Looks pretty good from here. At first I thought it was not 3D printed when I first watched this, but it seems to be very, very thin 3D printed. I think this is a piece of plastic over this, so you could look down in there. 3D printed bin that they had, you know, probably double its weight worth of other material in there. They had the powder in there, right? And then they basically, you know, shipped this one, and it seems that it is very brittle and tends to fail, right? And they've talked about this, that out of all the things they admit, the company admits, they say that a lot of people have this bin problem. Even 3D Printing Nerd also had this bin problem. And Short Circuit, which is a YouTube channel by Linus from Linus Tech Tips, Linus Sebastian. So they also had to get a new one shipped to them because it was broken in shipment.
This is not ready for anybody to buy. This is not ready for anybody.
Here's the key.
Multiple cracks in it. This is not ready for anybody to buy. They need to do more work on productionizing this. It's a great idea, but it is really rough around the edges. I've got powder all over me.
This is not something you want in this case, we'll talk about this in a second, but this is actually technically a beta customer, you can say, right?
This is ridiculous.
This is a switch button.
That have happened since I thought I finished filming. First off, this product is very cool. Let me make that very, very clear. But it is also very much not ready. And it turns out I'm not the only one. I spoke to another reviewer that I know has a unit, and he's experienced issues as well. And Micronics has not been very transparent about that. I talked to them late last night on the phone, and they led me to believe that other reviewers were having no problems, other than the SIP bin issues, which they said everybody has had problems with, and they're working on resolving that.
Crack.
They also have now multiple times asked me to delay my video under the auspices of so I get more time to play with it. But the dates they've suggested are all either at the end of the Kickstarter or after the Kickstarter ends, which leaves me feeling pretty uncomfortable, and I'm not going to do that. And I suggested that I think that they're not ready for people to use. It's not a good review unit. It's clearly going to be a very cool machine, but this ain't it. There's just too many issues. And so I suggested that they delay their Kickstarter by a couple months, work through these issues, and then release it. They don't want to do that. They said that they're running out of money, and...
Ooh, there it is. So, basically, he went in and suggested, I think his name is Scotty. Again, unfamiliar with him, but he's definitely earned my subscription. I'll definitely subscribe to him and keep an eye on this. But basically, he has told them, hey, you know, there's various issues, and me, he's got engineering background, which he'll describe. Me as a customer, I would not suggest anybody to buy this, right? And also as a YouTuber, I wouldn't suggest anybody to buy this, in his words. So then they said, hey, you know, we're running out of money. We are going to have to do something, right? And he's talking about there are other users that have had issues and they need to work through these issues. So let's continue, and then we'll talk more in closing.
That they need the money from Kickstarter to continue to refine the product before they can go to manufacturing. They then requested that I return the printer to them because, quote, "We felt our hard work was not appreciated." I'm not getting paid to make this video. I would have said that up front if I was. The only thing that I get from them is getting to keep the review unit and keep using it. It seems like what they were implying is that because I wasn't going to give a positive review, that they wanted the printer back so that they could use it themselves. I think first and foremost, I feel a real duty to be honest with you, particularly if you are or were considering buying one via the Kickstarter. I'm definitely torn though, right? This is a hard video to make because I want to see them succeed, and yet I don't want people to feel burned on the Kickstarter, and I feel the duty to be fully transparent and honest.
So basically here you have somebody that is a alpha tester. And again, they first said, hey, we'll let you continue playing around with it. But in the next breath, when he says, hey, I'm going to release this video, when I said I was going to release this video, they said, okay, return it. So, I mean, it is what it is. Like, and they said, hey, you know, we're running out of money for this. We have to do this Kickstarter in order to stay afloat, and so we can continue developing. So I'm not sure if they're just not trying to get any more, you know, any sort of funding rounds or give up any sort of equity in the company or whatnot, and just go directly to the consumer to keep it going. But there is definitely some issues here
with the experience that I've had. They also asked that I be very clear about what their solutions are to each of these issues. I think that's totally fair, and I'll talk through both what they told me to say and what I really think. First, I'm just a little bit concerned that if they're launching a Kickstarter in a matter of days, this is pretty late to be addressing some of these issues. And it seems like they're really only addressing these issues because reviewers are having problems with them, which really worries me. If I were them, I would have been shipping these units out, not as review units, but as test units to either friends or to creators like me, and saying, hey, can you help us figure out the bugs in this? And that's not what's going on here. They very much want positive reviews, and they're very much trying to shut down negative reviews. So let's go through the issues. So the auger jam, they're sending me a new auger assembly, and then they're planning to change the electronics and the software to support an unjamming routine. However, it's not really getting at the issue of why is it jamming in the first place and why is
so this is obviously a system issue. Like, okay, what is your controls? You know, is it severity over 4? I would say it's a 10. Machine doesn't work, right? Machine not working, severity is a 10. Okay, what is your mitigation plan? Okay, well, I'm going to do this rewind routine. Okay, with the rewind routine, then what are you looking at? Okay, well, what if the unjam routine doesn't work? Okay, I'm still at a 10, right? Okay, I fixed it. We've done marathons after this, and we'll talk about that in a second. Okay, how does it look? Okay, it's we've never seen it fail, right? Again, okay, so that is pretty good, right? How I would say that is drastically dropped to severity under 4. There you go. You're good to go, right? Obviously, 4 is not great. Again, under 100. So here for the occurrence, very high. It's a 10. Detectability is a 1 because it's very easy to detect. So, and I need to add another this one tab about how to come up with these numbers. And again, I can give you guidance, and then you can come up with your own thing after that. And then the SOD is basically the severity times occurrence times detectability. And if that product of those 3 multiplied together is greater than 100, then you still need to have a mitigation plan, right? And then if this is still over 100, then your mitigation plan's not good enough. Or if the post-mitigation severity is above 4, you need to do it. You need to relook at it.
It jamming when it goes into the machine. And so, like some of these other issues, I feel like maybe they're too quick to say we understand
because he tried the unjamming machine and it had no effect.
The problem and we have the solution before they've actually tried it. Henry was pretty clear. I don't really know why it's only happening when you put it in the machine. That doesn't make any sense. Which, as an engineer, that to me says it could be the reason that we're thinking, but it could be something else entirely, and it could take time and money to figure that out. Secondly, the recoder fault, and my understanding is the recoder is the arm that wipes across the new powder. They said that it's a known issue caused by the gear on the back of the build chamber not being fully engaged with the printer. And they said that it's because it's an off-the-shelf gear that they got off McMaster-Carr and that they want to custom machine their own gears. It doesn't really make sense to me because it failed 2/3 of the way through the print on...
Remember, this was like what? Listen to this next part.
Layer 649.
So 649, and it didn't fail the previous print that only had a tolerance change. So, this is another thing that would be caught in the marathon, and we'll go over kind of that in the conclusion of this video to go back to my hardware product development slides there and talk about this further. So basically, this is another reliability issue. Should be on the system Famica, right? The design system Famica.
Used that gear 649 times and then it failed, and it doesn't really have any marks on it. It doesn't look like it got chewed up. So I'm a little skeptical of that. They're going to send me a new gear. Hopefully it fixes it. We'll see. And then there's the sift bin issue, which I guess a lot of the other reviewers have been struggling with. And Henry said that maybe it's because they put the container of powder in there and it rattled around. It might have weakened the bin.
I couldn't even remember that part of the video. I just came up with that. But basically, maybe that bin is not packed as tightly in there as it needs to, the powder, and it moves around and just moved around and hit the wall hard enough that it cracked the wall. So I couldn't remember this part of the video. When I was listening to this video and doing something else, so I don't remember 100% of everything that I heard in this video. But obviously, we came to the same conclusion.
And then when I went to go shake the powder cake,
but this is a finalized shipping model of this now. Luckily, at least they did this to these YouTubers. Now, obviously, you probably want to do maybe even a pre-alpha. And we'll talk about that, which is to get products to normal people first, iron out most of the issues, then get it to reviewers, right? And some of these things I think would be hard to catch if not doing it 100% to how the customer is going to get it, actually ship it, and actually look at how it survives when you ship it.
It might have broken it further. They are planning to redesign the bin to be stronger, using either sheet metal or reactive injection molding. I think they also could do like an FDM printed nylon carbon fiber sifter and have that be strong enough. But of course it would need to be tested. I'm supposed to get all these parts later this week before
tested is the key.
This video comes out.
Remember, I will say in my hardware product development process, talking about copy exact and interchangeability, you test your fix on your site first before you ship it to customer. Don't look like a tool and ship something untested to the customer.
They're dead set on launching this on like June 13th or 14th, and I want to make sure that this video comes out to you around that time.
This was 2 days ago, and here's the Kickstarter. It launched, I think this is 3 days ago. Right.
So that you can make an informed decision on whether to back the Kickstarter here. So I don't know if the updates with all the new parts will make that video. It probably will just be a follow-on video to this one. And that's not me trying to do anything nefarious. It is just the nature of it takes time to edit, and I want to make sure this gets out in a timely manner. Normally these days when a company runs a Kickstarter, they're pretty close to being ready to do mass manufacturing. And I think that Luke and Henry think they are, and from my perspective, it seems like they're further off than they think they are.
So again, this is the whole part of the product development process that I'm trying to help with this Skool group, is that it removes this think part. It is, you have all of the procedures and documents or you don't. It is a binary choice. There is no think. It is, the documents are complete. The whole team agrees the documents are complete, and you have all the documents present, right? And we go over that again in the conclusion. But there is no need for this think. It's all aligned. That's kind of the whole thing, to get rid of this thinking and getting rid of these issues that will pop up. That's the whole point of being in this Skool group, is to avoid having issues like these.
Really downplaying a lot of what I would consider to be serious quality issues and user experience issues as minor. And I think from their perspective, given all of the research and engineering work they've done in the past couple years on this product, they are minor. But when it comes to selling a product for thousands of dollars to end users, they're not minor. These are really serious, show-stopping issues. Speaking from decades of engineering experience, if I've hit 3 issues this quickly and another reviewer has hit another 1 and is also having problems with the sifting bin broken, and this means there are undoubtedly more. They just need more time to refine this and make it more user-friendly and reliable. I really think that's it. But they're planning on using the Kickstarter money to fund that refinement, which these days I don't think is that normal. I think a lot of people really see Kickstarter as a pre-sales platform of, hey, I'm going to give you $3,000, you're going to send me a machine. And that money is really going towards manufacturing. And for a lot of people these days, Kickstarter really helps with the massive amount of cost that you need to invest in parts and production to ramp up mass manufacturing. Usually it's not spent on product development, which is, they're at the tail end of that, right? They're at the last 20% of product development, which is really refining and polishing it, which often can turn into the last 80%. And so because of that, I am very cautious about recommending backing this Kickstarter. You need to understand what you're getting into. If you want to see this product exist and you want to see these guys succeed, and you're willing to put your money where your mouth is, I think that's great.
And remember, during all of this, don't think about Micronics, think about it being your product.
If you think that you're going to spend $3,000 and get back a finished, polished machine, and that it's going to deliver on time and that everything's going to go smoothly, I don't know. I don't know one way or the other. Based on what I've seen thus far, that's up in the air. I hope that that's what happens, but I would caution you against getting your hopes too high. For now, backing the Kickstarter—
This is a terrible thing to hear from your customer, by the way.
—means funding future development, not buying a finished, polished machine. What I will say is that they are not as far along as other products that I've reviewed that are at the Kickstarter stage. So I don't know, all of that. This is a
Maybe you did another video on the Kavera Air. Maybe we should watch that one.
hard video to make because I want to see them succeed. I don't know what else to say at this point. I hope these guys succeed. I really do. But I'm not going to compromise my integrity and my relationship with you to help them succeed. So hopefully you understand where I'm coming.
Okay, that's basically it. 2 seconds left. Let's go ahead and go into final conclusions here. Take off my headset here. Okay, so basically we talked about the safety and design Famica. These are constantly updating. These are going to be only as powerful as your imagination. You're in your team's imagination, and you have to be as truthful on your safety Famica and design Famica as possible. If you need to push out deadlines for your product, that's what you're going to have to do. For example, this, because otherwise these guys are going to have to scrap this business and pick up again with some other idea, right? So make sure these are clean and they're always coming up. So for example here, maybe you didn't catch it, which I think is going to be very difficult for me to believe that these guys didn't catch these issues. Probably because, again, they didn't actually test it how the customer would test it, or do anything like that. And I've made these mistakes in the past. So my first product, I shipped it in a box with no packing material in it, and it absolutely destroyed. It just demolished everything. A big piece broke free and just went in, and just like a wrecking ball just destroyed everything, right? And then I had to ship all new components to each of the customers, right? So, and then when I get into big business, right, and learn more about this product development process, they have all these different testing parameters for shipping, which I will add. I don't have right now, but I'll add into the hardware development slides. So the bin, right, shipping with powder probably never happened. So sure, that would get through. But some of these things with like the marathons of the wipers, in some of their videos, the Micron videos, they show these wipers happening, that they have these test units running marathons. We'll talk about the marathon in a second. But it seems that would come up, and they know how to fix it enough that I think it is coming up, and that they're out of time and they have to push it. Otherwise, the company is going to go under. So if we look here, for example, the early bird, and you can see these are $3,000, $3,000, 3,400, 3,700, right? And basically, this is April 2025. So basically a year from now, but even a year from now is going to be tight, because if you look here, I think they already have 388 backers, and again, it's not in t-shirts, it's in regular backers. 206, so 25, 100, so 125, and then 300 and 330 something. So basically all of them are in machines. So now they're in 330 machines, and they have problems as of 2 days ago. So kind of rocky start for possibly a very, very promising product. And I'm going to be honest, the reason why it's saved here on my account is I was looking at becoming a backer for this. Obviously price is high, and it's a very SLS, very, very messy process, but I was thinking about it. So, again, design for safety, I'm going to push that a lot. So is this done, right? Safety FMICA, design FMICA, is that staying up to date, right? All these things. Okay, so let's go ahead and talk about maybe where some of these things got a little rocky. So let's go ahead and talk about the product development process here. So you have 7 phases, product plan. So they said, there's these other companies, they have an $18,000 printer and for minimum for SLS, and I am going to hit it at a lower market value by making it smaller, less weight, and streamlining it and making some parts out of 3D printed plastic to drop the price, and getting rid of having more exposure basically to the user than maybe some of these other automated processes of sifting out the SLS powder and getting rid of that. So that's basically your product plan. Okay, concept, CNF, concept and feasibility. I should probably put that in here. So concept and feasibility, basically, how could this product be accomplished? Is it realistic? Right? What parts are needed? What is the size, the shape, the weight, and cost to manufacture, I estimate. And basically, it's the how. How would this be done? And is this physically possible? Is there anything that I'm looking at that will break the laws of physics that makes it physically impossible? Or is the price plan I plan on targeting not even in the same ballpark as the cost of the parts? How many parts would I have to machine? How would I get it there? Is it where I can't even ship it, right? Is it going to survive shipping? Is it so brittle I can't ship it? Is the price of shipping just astronomical that nobody buy it? Things like this. Phase 3, prototype. They talk about it in the video. Maybe I'll analyze that in a later video. This is a pretty cool concept here, and I've enjoyed it thus far, and I hope you have as well. Prototype, and they talked about their different prototypes. Unfortunately, it looks like what he tested is still a prototype, right? So flesh out the system schematics, flesh out prototype BOM and cost. Okay, more realistic sizes and weights, and determine the performance of the prototype to kind of set the bar, right? and phase 4 is the alpha. Basically, this is sort of what you saw in that video, right? He was basically an alpha tester. Now, would you shoot yourself in the foot and send out an alpha that you are unsure about to a YouTuber that you don't know and possibly have a bad outcome? Probably not a good idea. If you're a little shaky and you have some extra time, do a pre-alpha. Do like a phase 4A and do a pre-alpha and ship it to not YouTubers, ship it to individuals, friends and family. Do it the same process that it would be that you would do normally. So, for example, if you want to test your shipping, ship it to the other side of the country and then ship it back. Ship it to some warehouse somewhere and say, hey, I'll give you this amount of money. You ship it to the warehouse and then ship it back because I'm testing my shipping quality. And then you can do that as many times as you want. It's going to cost you 4 days maybe to have it shipped across country and shipped back by ground, right? So do a pre-alpha, get it to some people that you know, and or some people that aren't YouTubers and aren't gonna, blast you because your product is in an early state, which it is. It's an alpha. It's even a pre-alpha, right? So, yeah. Or you could even call it a closed alpha, is what they call it for video games. They call it closed alpha and then an open alpha. So this would be more going to YouTubers and the YouTubers releasing the information about it because they're not under NDA. They're just going to tell you that guy was definitely not under NDA because otherwise you wouldn't be able to say what he's saying. But so do a closed alpha, right, with people maybe even under NDA if you're worried about it. So say, hey, we're going to sign an NDA. I am going to pay you to do this, or I'm going to not pay you to do this, and you get to keep this, and I will send you a finalized version and give you full life maintenance on it or whatever, right? And then alpha, you get it to open alpha, you get it to the YouTubers, and then they release information about your product. So basically where they were at is they were pretty much at the closed alpha state, it seems, even though they shipped it as a open alpha. And so they kind of got roasted there. And even in Joel's, which is the 3D printing nerd, you can see his sifting box has got duct tape on it. Now it seems like he had a better use of the machine, and that it seemed to work the first time more so, but still, right? Then you have so would have shipped a closed instead of this being an alpha. I said that the Micron would probably be a closed alpha, and then finish that off, then send an open alpha, and the YouTubers will talk about it, and then you can say, hey, I want my Kickstarter to be a beta. It's really good. I have learnings from from the closed alpha. I've integrated them, and now I'm doing an open alpha, and that's all gone also very well, and way less issues than the first closed alpha. Okay, the beta should have next to 0 issues. Okay, this is going to Kickstarter, guys. I'm getting them, a deeper discount and more benefits and things like that. More keeping tabs of the product and getting longer warranties, etc. All this stuff. Okay, that's all good, and then you could roll into phase 6. So they just rolled into the alpha, I think, too quickly. And again, a lot of these are talking about, and this is I'm polishing up further and further. Again, this is an information gathering phase, but pretty much right here, right? So you would have, MRS, which is a market requirement sheet. So basically, what are your specs? And a big one that would be here is MTBF, mean time between failure. So, okay, is it every 100 hours you should have a failure, I'm talking about throwing a warning or whatever. In this case, obviously, that guy had 30 seconds. 30 seconds, Scott, I think his name is. Scott had 30 seconds until his first failure. So, mean time between failure is terrible. Uptime of this machine is terrible, right? So things like that, right? So here, gate 4, so you would have, and these are gates. Basically, gate is from phase to phase. So from phase 2 to phase 3, that's a phase 2 to 3 gate, right? And then you can only get to the gate to the next phase if these documents are complete. And obviously this I'm still working on. You can always go to the classroom and click on the product development here. There's a link in there that you can follow. So basically here is talking about, prototype system schematics, electrical schematics, flow chart of the software. How does the software work? What is the proper way the software should work? So that if it is not working that way, I know there's a problem. If you have a program, it's fully commented, ready to go, cleaned up for the prototype, complete prototype BOM, finished, nice functional prototype model, and prototype specs. And then ideally it is meeting your MRS that is expected in the concept feasibility. So basically it is meeting your target performance for the market and for the price that you want to target. So your prototype, right? I already went over that. Alpha. So alpha, here you go. So main one here is marathon transparency data. So basically if I get multiple pieces of equipment and I basically run them together, how close are they transparency to each other? How repeatable is my performance that I'm supposed to have on my MRS? Am I getting 5% from machine to machine, or am I getting like 1%, like really good, right? And then how's the transparency like if I change something, is it completely throw the whole machine off? Like if I put it in a different environment, or if one of the machines is under like a ACE air conditioning register, does it throw it way off? Like if I put this throughout different places in my shop, does it do the same thing? Maybe you can mess around with dirty power. If I have a little bit weird of a grid, or if I have a European grid, what happens? Does it perform the same? So things like this. And marathon is however you want to define that. I may help you define that here. But basically it's doing accelerated testing, right? So you are running this thing like 24/7. What's going to happen, right? And maybe even doing more models than the average person would do, right? And so here you would have, manufacturing procedure documents, manufacturer testing Q&A, and safety documents, control system and safety documents, alpha system / design, FAMICA, safety FAMICA, updated MRS, right? So you would have all this stuff in the alpha, any sort of manufacturing procedure. And I think in here, I don't have any. So in here you would have control system safety document. So in here also you'd have, your operating. So you'd have like an alpha. So you'd have any of your other operating manuals or other procedure documents that you would provide to your alpha testers, either your open or closed alpha testers. Same deal here. So I'll bring that in here, but basically the same thing here. Designed for protection analysis. So what that means is basically how are you going to protect your prototype? Do you want to make deals with these manufacturers to strip all their information off of your material, any sort of off-the-shelf OEM parts? Do you want to force the customer to come back and buy the parts from you instead of being able to go directly to the vendor and buying the parts? For example, if I have a stepper motor and it says exactly where, the manufacturing's label on there, they're going to bypass you as the actual manufacturer of the product and go and buy the motor directly if there's a price differential, right? So this design for protection will help you do that with any sort of agreements. And so at that point, you want to start to look at the design for protection analysis. What am I going to protect? What am I not going to protect? What does that impact, right? So, yeah. And then here you see the full product release. So full release version, right? FRV, full release version. So you can see we have a lot of different things, right? All legal documents that you have to have some people sign or whatever. What is your ramp up plan for manufacturing? Your manufacturing plan in general once you get up to speed. So ramping up to speed and then up to speed. And what is your marketing plan? Revenue, market plan, and forecasting. OBS is obsolescence. So what happens if a part is no longer available? How are you going to handle that? and then your OEM and manufacturing lock them into a pricing agreement. Otherwise, you hit, you know, some huge demand and they gouge you for prices because now they kind of got you by the balls. Anyways, and then the product life cycle. So again, obsolescence, keep up. So this is what I was talking about. Keep updating the design system FMICA when things come up, and do mitigation if needed, changing in pricing, etc., recalls, stock replacement parts, have them on hand so you can provide it to your customers. Keep your uptime, your mean time between failure and your uptime very high, etc., right? And then have an MRS exit criteria of when you want to basically exit the market, right? And no longer provide end of life, basically end of product life. Okay, so that is basically my analysis. So they basically have a year to clean this up and pretty much go back, use the money that they get from the Kickstarter. I mean, right now, where are they at? They're at 1.33. So basically today they got, I think maybe $500,000, $500,000. Oh no, sorry, like $150,000. But it's definitely slowed, maybe because of this video. I'm not sure. I don't think it's got 68,000. I mean, maybe, but we'll see. I mean, obviously, a lot of people are 68,000 for 3D printers. Some people are into it, so most likely a lot of the people have seen this, and maybe even they're talking about it in the comments. 122 comments. So we'll see how this pans out. I'll find some other videos, and maybe he's got an engineering. Scott here has an engineering background. Maybe we'll look at some of their Carveras or some of their other some of the other things that he's reviewed, and look at that. But overall, that's all I wanted to talk about now. Go ahead and send me any questions if you have any, and let's move on to the next one later.